cold. Actually, these are all hot. For the like boosters for the HVAC system, the VAVs, so they can adjust temperature. So basically, it rolls. It runs the water through the coils. Air passes over, helps heat it, cool it. Now there's large air handlers all the way up on the roof that supply conditioned air to the space.
Is the walls already painted?
They have started priming paint on some of the walls, yeah.
When was this part of the
So the frame, our process was framing goes up, MEPs go in wall overhead. Once they're done, then we do drywall and pave, okay? And then they finish their overhead, and we'll start closing up ceilings. So those big lines that you're seeing up there are for basically storm drain. So those were, yep. So there's like a little balcony area, let's say, on the second floor. So any water that gets on that deck will make it into the storm drain. Some of these run all the way up to the roof. Anything that gets on the roof, make it into those drains and out.
So these make them travel out.
Yeah, and if you come over here, you'll see on any of the interior storm drains. See the pipe sticking out and the one down below?
Yeah.
So the one that's sticking out and attached to nothing, the one below is called the primary. That's tied directly into the storm drain system. The one that's sticking up is called secondary. So up on the roof, you'll see two roof drains. The concept is the primary is set a little bit lower than the secondary. So the idea is all the water always goes into that primary now. Secondary is just that. If something happens and that primary gets backed up, you don't want to create a pool on your roof. So it'll go down to the secondary, it'll just pump outside the building. So that's a common thing you'll see.
What did you say the top one was for, or the secondary?
Secondary is basically if you're up on the roof and there's two roof drains, it's set a little bit higher. So that way if for some reason the primary can't keep up with the volume or gets clogged or something, the water as it starts to fill up on the roof, it'll start going down the secondary pipe. So no matter what, you're getting the water off the roof, you're not creating a pool up there.
Okay.
Keep walking. You guys got questions, fire them off.
So all most of the walls that are on the exterior have insulation, or at least every wall does.
Every wall's got a installation. On the exterior, there's you see you call them Z-metal. So not only is there insulation in the wall, there's gonna be insulation between the Z-metal and then the metal panels are gonna go on over that.
So there's two types of insulation, the one that's behind that and the one that's going to get installed, right?
Yeah.
Those have been done to these walls already?
What's that?
These have been done to like these walls that we passed by already?
You can see the insulation in here. So that's the exterior skin, just the insulation and over the waterproof membrane. So this is gonna be like a fire sprinkler, fire alarm apparatus. So there's gonna be a rack right here, and there's gonna be a bunch of the fire sprinkler system running on top of that rack. There's gonna be a lot of fire alarm, devices on this wall, demonstration purposes.
Is this gonna be an enclosed area, or is it gonna be open?
So, between steel there and there, it's basically gonna be like current wall, so store is gonna have glass. So if you're up there walking and you look down, you'll see people down here. But yes, it's gonna be weathertight.
These are going to be future classrooms, right?
Yep.
Oh, okay.
So if you ever hear the word soffit, this is a soffit. You can imagine so like what's the difference between a ceiling and a soffit? The ceiling typically covers wall to wall. A soffit typically has a drop and a return back to the wall. Or sometimes it's just a soffit that's hanging down but doesn't extend all the way to the wall. Halfway. So behind this, under this unit here, there's a large shaft that goes all the way up to the roof. And there's a duct across each floor. And so that's what you're seeing here. That's why this duct is so big compared to the duct we saw at the other end. Right? Because it branches off from the supply, right? So get into the engineering, did from the source unit on top, you'll see the larger duct as it makes its way out to its final destination. Obviously, you don't need this much volume of air for one room, so it branches out. But each time that a section of duct taps off, it takes some of that volume. So as it continues and continues, the duct size reduces. So you can see the size of it here, it's already reducing, but it splits in two directions, right? So it's feeding that side and that side, and as it continues to branch off, you'll see it reduce and reduce. And there's calculations that they perform to make sure all these bends change airflow, and so they do calculations on how much airflow they need in each room, and with that, they size the duct and work it all the way back to the unit. So that's all part of the stuff that the engineering design team is doing.
What's the purpose of this?
Of what? Sorry, the what?
The copper bar that's
As I mentioned earlier, so this is the VAV, and what it is this is almost to like heat up the space. They'll run hot hydronics through. It runs through that hot water supply, like goes in, passes over the coils, and return line goes out, right? But what happens is as air passes, it'll heat up. That's how it'll heat up the space. Basically like a little booster. This pipe is as hard as sprinklers.
Oh, super.
So you have the sprinklers up on top.
Oh, yeah.
You see the movies and there's an explosion or a fire and all the fire sprinklers turn on? You think that happens?
yeah.
You think they all go off at one time? So if something happened here, the fire sprinklers are gonna go off over there?
Just in the area that
I'm asking you.
In the movies, it shows everything. Every single different rooms, that's the church.
What do you think?
Is everything contained with some sort of activator?
So what's your guess?
a sensor.
I think it's just one area.
One area?
Yeah.
Maybe it's surrounding,
Okay, so it is one area. So each of if you look up on the head, probably hard to see, but there's like a little vial, it looks like that's in there, right? So it's that little vial is basically designed at a certain temperature, it will break. And once that breaks, this thing is always constantly under pressure, and it'll start shooting out, right? But just because, let's say there's a fire in this room, the system's not gonna be draining over there or wherever, right? It's isolated to the individual location. But at the same time, if a contractor breaks one of those, it'll start dumping water. And we do keep our systems under pressure, just for that very reason. You know, we're drywall, we're doing these things, we're putting screws in the walls. You don't wanna find out later that somebody, you know, hit a line or damaged a line, rather know about it when it happens.
Are they activated right now, technically? Like,
Yeah,
let's say somebody
we
gets on
keep
fire.
them under pressure.
Yeah.
So we notify the trade that, hey, first floor, quad B, fire sprinkler's under pressure, and, you know, trades aren't supposed to damage other people's trades, but things happen. Alright, keep walking. You guys have a time limit, tell me, you guys are, I'm just a tour guide. You guys got something you wanna see, or need to look at, or have a question on, by all means.
In terms, because to my knowledge, you'd have to wet this for grading and landscaping. But in terms of pouring the concrete for this portion of the foundation, it'd be what the concrete have the rebar and then let the soil rebar and then concrete. We're
This-
talking about 16 foot.
So this building is a little bit unique, has a mat foundation. Just give you another aerial. So, anybody know what a mat foundation is? What's that?
On that foundation?
Yeah. So traditional buildings are like either spread footings or have some continuous footings. So if it was like your house probably has like a continuous footing around the perimeter, and that's pretty much it. If there's a or like where your load bearing walls are inside the building, they'll either have a spread footing, which is basically an isolated footing to pick up that column, or it'll be like a continuous along the wall, right? So a mat foundation is basically, instead of footings just under the wall or the column, a mat is the entire, under the entire section. So this building, on this floor, it varies from, I think it was 4 feet to up to 16 feet. And in different areas, depending on the seismic calculations that they did, at different depths. So we had, you know, a 12-foot difference in mat thickness. So then above once the mat, so first you go through and you grade it. And grading, you dig, there's a soils report that tells you how much OX you have to do. So in this, you know, let's say we had to go 5 feet under the bottom of the mat. So if this area was 16 feet deep here, we had to go another 5 feet deep. So we had to dig 21 feet down, fill that 5 feet back up, and then we would do the rebar for the mat. And once the mat foundation was poured, then we had to do sections of the vertical, which would be our shear walls and columns. Once those are up, at least to a high enough level, we would start because it was a mat, we then had to fill basically 2 feet of sand between the mat and what would be the subgrade of the slab. And then once that sand was there, we ran underground utilities, so plumbing, electrical, underground. And then once that was done, then there's a vapor barrier that goes down over the sand material, and then there's rebar that goes on top, and then we place it with concrete. And then that's how you get to this point.
What almost equipment or like big tool would be used to dig out for the foundation? 16 feet.
Sometimes we had This project had a scraper on it at one point in time, excavators, loaders, heavy equipment. So like you saw, some of the excavators on top and smaller loaders, those were small compared to what's used to do the grading. So this is where the tower crane used to be. Now the tower crane's out. This is gonna be like an amphitheater seating on this side, and then there's gonna be a stair that goes up there. See this chunk of rebar that's down and out and over there? Once we pour this out, we're gonna put formwork in, and then we'll continue the rebar, and that's a set of stairs that goes from there to there, and there to there. So those all become stairways.
Are those going to be welded? Much tied.
So they call them lap splices. So in rebar, you'll come to basically how they engineer them. So again, they do their analysis and they figure out the bar size, but it's not feasible, like in this condition, that we had the tower crane here. We couldn't do this work until this lower section was done. So what you see here is basically the rebar doweling out to get picked up on the next phase. And we determine how much needs to dowel out by the lap splice requirements of that bar. So the size of bar, the mix of concrete, determines how long that lap needs to be. And the lap, it basically justifies it to be almost be one bar. And there's are things that you can do. You can weld bars, you can do couplers, common and lap splices.
What type of equipment do you guys use for that? I heard the scraper, an excavator,
A loader.
loaders. You said small loaders as well, right? Just loaders?
In comparison to ones we've seen, the ones they had to use down here are much bigger.
Any other equipment?
Let's get we use the blade for the roads. You name it, we've had on this side.
One